Hey everybody, Swarsky here. Today we're going to talk quick about power functions. Now, just as a quick kind of difference between what we've already dealt with, exponential functions, and what a power function is, let's just talk about that real quick. So the way we've dealt with exponential functions, that's in the terms of y equals, let's just call some variables a, b, x. The big piece of that is that there's a fixed base and the exponent is variable. Now for a power function, that flip-flops. So when we'd write that, it'd be y equals some coefficient x and then n, where we'd write this as the, we'd say it's a variable base and a fixed exponent. Okay, and that means that we have to deal with solving that a little bit differently. Okay, and that's what we're going to talk about. So we're just dealing with solving some of these. So a real basic one to solve a power function would be something in terms of, let's just use, I don't know, 5. Okay, x to the fifth, and let's just say it's 21. Why not? Okay, well, how do we solve this? Well, we use our properties of rational exponents, meaning I'm going to multiply this by, or I'm going to take this and able to solve for x. I need to take x to the fifth power and multiply that, or take that to the power 1/5, which means I need to do that with this piece. So hopefully this is ringing some bells from what we did before. Okay, and then I can just simply solve. So let me go back because I have my calculator. So that means I go 21 to the, and what did I use? 5, 1/5, or 1 divided by 5. Delete. Hold on a second. Oops. Try it again. 1 to the, choose that. So we get right, if we round to the nearest tenth, we'll just say it's about 1.8. Okay, so I know that x would have to be about 1.8 to be able to make that work. That's the basis for power functions, for solving those, is I'm going to end up using my rational exponents to be able to solve that. Now, obviously, this was a very basic one. We can start getting a little more complex, meaning we can start adding coefficients. So instead of x to the fifth equals 21, if we just go 3x to the fifth equals 21, I would simply just, in the beginning, divide by 3. So then now I'd have x to the fifth equals 7, and then I go through the same process of taking 7 to the 1/5. Okay, let's just look at one more complex where I can now start looking at it as, oh, let's get a little bit crazy here. So let's say x to the, so let's say that all divided by, so let's take that 10. Okay, same process. So I go through kind of my balancing here to get the power function kind of isolated. So I'd multiply by 5, 50 divided by 2. So now I'm really sitting with x to the negative 1/5 equals 25. Okay, well, now how do I deal with this? Well, the same way, where this is actually the same thing as saying that this is actually rooted. So I can actually take this to the power of, so if I were to, wait 1 second. Okay, move this down. Yes, no, yes, no. Let me move all this over. Give me a second. So I'm sitting now with that. Well, I could just simply just take this, oops, and now I could take it to the negative 5, which means I just take 25 to the negative 5, and then I could solve that way. Okay, so I'm using my rational exponents to be able to do that. Okay, I could also look at this differently, where I could say I could still use this power function, or it is still a power function if I have, let's just say, oops, let me use a different one, 3. Let's go like that. Oops, actually, I'm going to erase that and make that the x. So it's got to be variable. Let's make this 10. So this is actually still a power function because this rooted value here can actually be rewritten as, like we've already done, like that. Okay, which means now I can just simply take this to the 3 halves. Okay, that's our basis for solving these power functions. Okay, and we can start getting other things with, we can go like x to the all these kind of things. And it doesn't matter what those values are. The whole thing is that we want to end up getting this power function where it's in this terms to some value, which in this case would be what? Times 2, so 14.4 minus 4, so what would this be? 10.4. Hopefully my quick math was accurate. Then I could just take that to the 10.4 to the negative 1 over 5 exponentially. So I'm just using those rational exponents to be able to solve. It doesn't really matter with the complexity. Just realize that you can rewrite it and get that. So that's it for now, guys. We have some practice for you. A couple of those. I think we have a couple of them, 10 or 12 things for you to practice, and then we'll get to applying tomorrow. Hopefully you guys have a great day. If you have questions, come stop in on the office hours. Have a good one.